Ja, hallo und herzlich willkommen zu meinem Vortrag. Wie Matthias schon angekündigt hat, ich zeige euch heute, wie wir mit
Yeah, hi, and welcome to my presentation. As Matthias already said, I'm going to show you how we do hydrolocal monitoring and how we have 100 Nagios installation using CheckMK. So first of all, I would like to tell you a little bit about Faurecia. Faurecia has sales numbers of 70 billion euros of sales, so that's why we are one of the top suppliers in the automotive industry. We're also always present where our customers are. We're in 35 different countries. We are leading in clean mobility, interiors, and seating. And we develop products for clean exhausts, interior, and also seats. So each third vehicle in this world includes technology by Faurecia. We have 6,000 engineers in 30 development centers, and in 2017, we sent in 370 patents. 350 experts are working in 54 strategic areas. In 2017, we had 160 million that were invested in innovation. That's 23% more than in 2016. My own location in Augsburg, we decided to spend 10.6 million euros in the innovation park in Augsburg in order to have new technologies to save weight using carbon fiber in mass production of vehicles and doing that in a useful way. Carbon fiber can be used in order to save 50% of weight in comparison to steel. 10% saves 1 gram of CO2 per kilometer. Faurecia employs 109,000 employees all over the world with 90 different nationalities, and 30% of our workforce is female. Every year we have about 10,000 new employees that are recruited. Faurecia has locations all over the world, so that's why we can deliver just in time and just in sequence directly to our customers. The logistics process is then based on systems, and there's data exchange with our customers on a continuous basis. If one of the IT systems doesn't work, it very quickly makes it where there is a stop in our supply chain, and that can also make it where our production has a standstill. And that's why monitoring of these IT systems is very important, and also early on alerts are imperative for us. And this monitoring still has to work if there are some connection problems. For that reason, we have a locally installed monitoring system in every single location. When I began working in the monitoring team in 2016, we had about 300 of those locally installed systems based on Debian 7 and Nagios 2. And Debian 7 was a copy of the repository of 2014, and it was not actually worked on since then. Since we mainly use Windows servers in our locations, this NSK client is being used, ++, of course. And our web front end for configuration is Fruity in an adapted version. And with that, it was possible for us to have one central server, and we could actually deploy hosts and service templates. And obviously, a change is needed because it was very much outdated environment, so everything had to be updated, and that was the start of our project Hydrolocal Monitoring. Okay, so what kind of requirements did we have when it came to a system like that? Security, of course, is very, very important when it comes to IT. And of course, it had to actually make it where we have security patches, applications for that, current software and operating system version. We went with CentOS 7 because that is a good standard when it comes to engineering. In addition to that, we also had a central control of our directory, and by doing that, we also had password guidelines that we were able to implement. And for the implementation of these systems, it was very important for us to have all different installations going through a standardized configuration so that they're all identical, and the user would have to intervene as little as possible and could also influence it as little as possible. And this implementation had to be fully automated, and it had to have a high degree of industrialization. Talking about operation, it was very important for us that we have these possibilities that have a standard in monitoring, and that we don't have any individual values per location, that we can also avoid monitoring being turned off. And with Nagios, we sometimes had the problem that local IT got alerts, and they didn't know how to turn off the alert. It was just alerting them every 5 minutes, and then they just set the check on passive check or active check disabled, and the problem was solved. However, they forgot to activate it again. And next time they had that problem, there was no monitoring, no alert.
Weiterhin wollten wir auch noch eine standortübergreifende Übersicht über den Zustand der IT-Systeme für unser Management.
In addition to that, we also wanted to have an overview of all the IT systems of all different locations for our management, and also automatic reporting. And in order to increase acceptance, there had to be a quick and easy way to configure hosts for this monitoring. And as I mentioned in the beginning, monitoring also has to work when there is no connection. Okay, so how did we approach this project? Well, in the first half of the year of 2016, we had a proof of concept with CheckMK. And we did that in order to validate that the monitoring could be done the same way as we did in Nagios. We had some Nagios plugins that we developed ourselves in order to monitor critical processes in our business, and they were still supposed to work. That was very important for us. And in addition to that, we had to check that the monitoring software fits into our organization and supports us. In the second half of 2016, we then started our pilot phase, and we defined 7 different pilot sites in 4 regions: Asia, EMEA, South America, and North America. And we then involved our level 2 support from all 4 regions, and also local IT from every location was also included. And during the pilot phase, we wanted to validate that the software fits our needs, and also that we can actually, sort of replace the Nagios 2 environment. And in addition to that, during the pilot phase, we also defined and validated all the general settings and the folder structure. So, for example, authorizations and, like I said, folder structures, things like that. And in addition to that, we also set types to cover the scope of current monitoring, and I'm going to talk about that in more detail later on. Our go live took place last year in November of 2017. And when I left the office yesterday, we had 111 units that were already installed, and 25% of the project has been completed. So how did we implement that? Well, I brought you just an example of that configuration. Each location has a code, a 3-letter code. I have locations A, B, C, D, F, G, and X, Y, Z. And we have one master in the European center, and this master is only used for configuration and maybe also for reporting. Each location then has their own slave. We call it Hydra Hat, and location ABC has their own head. and DFG and XYZ do as well. That's very important if there's no connection. In order to make sure that alerts can be sent, we have text message alerts since we have a central email system. And the user should then, in order to see the monitoring view, only connect to the local Hydra head. And if there is no connection, for example, they know exactly where they can access their status. In order to make that possible, there were some changes that were necessary within CheckMK. First of all, we had to work on the live proxy status in order to make it more scalable and also to make it where we have 300 sites that can be monitored simultaneously. In addition to that, we also have the user object and we also have the option over sites in order to make it where the user can limit it to their site, and that way they only see the sites in Activate changes that he's responsible for. In addition to that, we have a separate plugin for Faurecia in order to base everything on the membership in our contact list. And it's also possible that a member of the local IT is responsible for many different locations. And of course, that person would then see 2 or 3 different locations depending on his responsibilities.
So, wie haben wir das in der Vato Ordnerstruktur umgesetzt?
Okay, so how did we do that in our Wato folder structure? Well, there are 2 main streams, as you can see, and one of them is the folder infra on the right-hand side, and then also local monitoring on the left-hand side. And under infra, there are 2 folders, one for each country, and those folders then include the host objects for monitoring of Hydra heads. And infra, that's the monitor master, and that means these heads right here, they are then monitored by the master. And on the left-hand side, what you see is the folder local monitoring, and you see 2 different folders under that, so 1 folder for each country, and under that you will find 1 folder per location, and the location folder is then connected to the local Hydra head, and then below the location folder there is a pre-configured set of subfolders in order to organize everything else. And I do like the structure a lot. I do like the snap-in 3 folders. That's very, very easy to understand and straightforward. Okay, so how did we do all of this in Active Directory? How did we implement it? On the left-hand side, we see the Wato view. On the right-hand side, that's the Active Directory. The Active Directory group memberships are used with an identity access management system, and the groups that you see here, they're also used for different purposes, admin, access to servers, network components, etc. So they're not exclusively used for monitoring, and they were also there beforehand. We just integrated them the way they were. And there are also different groups per country for level 2 support, and that is then needing access. And of course, there's always 1 group per location for all local IT needs. On the Wato side, you see the same contact groups, same names, and there's 1 for the folder DE groups, for example, and then also per location, DE ABC group, which then has access to the location folder and all subfolders. All of that is then synchronized using LDAP, and we're synchronizing every 6 hours, and we synchronize about 1,500 users from our Active Directory. Okay, so how are Hydra heads installed on site? Well, that is a 47 MB boot image for installation with Anaconda in Kickstart, and that is done by Specs, Route, and Coupler. And it's a fully unattended installation and also the configuration of the operating system with all its components. And of course, you can also set up the site using OMD, and then also the automatic backup is there, text message alerts, and also the computer is also registered in the Active Directory for admin access. Installation takes about 20 minutes to 3 hours, depending on WAN speed. And the same holds true for Wato Web API. So the connection is also done in distributed monitoring via Wato and API. There are also contact folders and host groups and the corresponding rules. And there's also one host object for Hydra head in the infra folder structure, and also one host object in the local monitoring folder structure. That is important for text message alerting, because that way local IT has a view to the text message server, so the modem is there, and also that there is the appropriate signal strength. So as soon as the head is installed, local IT is sending us a ticket, and we then have to use Wato to activate the site in distributed monitoring. It's set to disabled, so you have to log in, and this monitoring object has to be activated. All of that is happening via a very simple web front end, and that's really what triggers the installation. And that's what it looks like approximately on the left-hand side. You can see the web form. The user is filling in his information and then sends it out. And then in the background, there's a communication taking place between Cobbler and Spacewalk. Spacewalk is then setting up the system, and Cobbler is doing the boot image and the Kickstart script. And at the same time, we also have communication via the web API with CheckMK, and you see distributed monitoring, contact groups, host groups with rules, and also all the folders with authorizations. Yeah, and I would just like to show that using a short demonstration, just so you can see what it looks like in real life. Oh, I'm sorry. Okay, so this is what it looks like in CheckMK, distributed monitoring. This is the site. This is just ABC for now. And there are host groups. There is a host group, as you can see here, with the corresponding rule, or folder structure, and for folder DE, and the host object for the location ABC. And local monitoring includes the folder DE. And what you see right here is the level 2 support having access to this contact group. And for the location folder, oops, sorry. The location folder, we have the corresponding contact group for local IT. So once local IT is requesting Hydra head, that's the web form that I was talking about. So local IT then chooses its country first, DE for Germany, and then the location, DFG, for example. And then you can also change the time zone. The browser is determining the time zone, but sometimes it could be possible that you're maybe installing it for a location, a different time zone. So if that's the case, you can also choose your time zone manually. And then you have to type in the IP address, network information. That's standardized in our case as well. Then also the net mask.
Gateway, das ist alles. Der Benutzer kann das Formular dann wegschicken.
Gateway, that's it. The user can then send the form and then gets all the information as a summary. The name server don't have to be filled in. We get them from LDEP, from the Active Directory sites and services, automatically for each location. And that's also standardized in our case. So if everything's okay, he can then confirm and then also generate the ISO. So you get the corresponding boot image to download as well. So like I said, it's 47 MB. You can download it and you can start it, and then installation is happening automatically. And if we now go back to CheckMK, we see that the site was created. It's still disabled at this point, and there's no login so far. So like I said, installation is still taking place, so it's just started, and you just have to wait until that has completed, and local IT is then sending us a ticket, and we then activate the site.
Genauso hier die Kontaktgruppe ist angelegt, die wird dann eben alle 6 Stunden dann mit User befüllt, sobald die da ist.
Same holds true for the contact group. It's also created, and every 6 hours it's then filled up with users as soon as it's there. It takes a little while. Sometimes that leads to some misunderstandings because some people want to use that system right away, but they just have to be patient for that sync to actually, be completely completed. Then we also have host groups right here. They're also created with rules, with the corresponding rules. And we also have the infra folder of the host object for central monitoring. And like I said, that's also deactivated just so you don't have any false positives for now. So we'll only activate that once we have the go that installation has been completed. And in local monitoring, we also have the location folder with the contact group for local IT. And all the different subfolders.
Das ist die Sicht, die der Benutzer, die lokale IT hat, wenn sie das System
So that's the view that the local IT gets, the user, once they are installing the system. So they're just choosing this entry right here. If they boot this image, they just choose it for the host name, hit enter, and everything else is going to happen automatically. So it's pretty straightforward and very simple. Okay, so once the Hydra head is installed, you just have to fill it with life. In order to do that, and in order to make it as easy as possible for local IT, we have types that are preset, and they make it where there's efficient configuration of monitoring for different devices and applications. And local IT, the end user, doesn't have access in Waito to services, so he cannot uncheck services. That can only happen via the discovery service by CheckMK. I think it's every 3 hours in our case. And the settings that are necessary, for example, for Windows servers, the standard that we have antivirus software, all these different things, all of that is then being done via rules and tags. That's how it's managed, and the user does not have to think about it at all. Doesn't have to think about what kind of settings are needed, and that is just defined worldwide. It's standardized, and easy to use for the end user. In addition to that, we also, when it comes to Windows servers, we have different options. As you can see, you can choose if you want to have a print server, for example, or if you want a backup agent or backup media agent, for example, or if one of our specific software is necessary. There are some exceptions that we find in the descriptions of the corresponding units on the monitored devices. For switches, we don't monitor all different interfaces, as Alexander Wilms said. We don't want that. In our case, we explicitly do that with an indicator in the interface description. That's how it's enabled, as I heard in the previous speech. So we use square bracket M in order to activate this monitoring for the switch. Local IT can do that on their uplink interfaces, server interfaces, and they can do it and configure it and then use the auto discovery check in order to activate this monitoring. We have the opposite case in file systems. There are some file systems that are only temporary storage spaces back up to tape, for example. They're always full somehow. I'm not an expert when it comes to this area, but what they didn't want was monitor these file systems. Because of that, we do the exact opposite. So local ID can actually access the description of the file system, square bracket for NM, no monitoring, close a square bracket, and then this file system is automatically excluded from monitoring. And in addition to that, we also have bulk import. So in order to do that, we also have an Excel front end that we built, and that makes it where local IT has a very easy time doing a mass import of different hosts, and that is being done via the bulk import. You can see that. I can just show you that as well using a short demonstration. So that's how it should be. So maybe just very quickly, check MK. If the user adds a host, you just enter the host name, IP address, and alias. And that's really all he has to do. And then you choose the host type, so Windows Server, and then maybe also print server, and maybe also a backup agent. And that's all he has to do. He's just saving that, activates it, and then using the auto discovery service, all the necessary services are monitored. So I hope you can see everything. I'm going to try to make it a little bit smaller. The screen is a little bit smaller than expected. Is that okay? Can everybody see? Okay, so this is one of those Excel files that we created in order to make mass import a little bit easier. So there's always some inventory data available in some way, shape, or form, usually in Excel sheets where you can just copy, paste. So I'm just going to do it very easily. I'm just going to do Excel fill-in. And I'm just going to create 10 hosts very quickly. Oh, that's the host name, sorry. That's what it was supposed to be. IP address. Alias.
So, und dann kann ich hier anfangen, meine Host-Tags zu vergeben, wie beschrieben. Kann ich sagen, okay,
and then I can start using host tags, like I said. Ooh, that's difficult to read, sorry. Very difficult to read, I'm sorry. Okay. So I can't show you really, but I think you understand the idea behind it. So I'm just choosing, I'm just going to have to make it a little bit bigger. Okay, now it's fine. So I'm just going to show you this, the core switch, H switch, maybe also a wireless LAN controller, Windows server, another Windows server, and maybe I also want to monitor the hardware. That's a separate object. And then we also need a storage system, a printer.
Kann dann hier noch den Application Type setzen für meine Windows Server. Kann hier sagen, das ist mein Primary Chip System.
And we can also set the application type for my Windows server. So I can say this is my primary system, this is my backup chip system, and I then have all the data I need. I can then save it as a CSV file for later import, or I can just do copy paste and just copy it for now, save it, and then go back to Wato. I can then do bulk import. Ooh, hold on. Bulk import. Bulk import. Oh, here it is. Okay, thank you. I'm just going to copy the content, upload it, and then I just have to say that I have a header. I can also do an update, so it looks good so far. I can just check again, and I can then make it where I created just 10 hosts very quickly, and I can activate it the way it is right now. What's missing right now is the parent-child relation. That is something that has not been implemented yet. That could be a good idea, though. Maybe the developers could listen to that. Maybe via bulk import, we could also add parents. That could be good. We requested that, but I don't know. That's just an option. And yeah, it's a very easy and simple way for local IT to do their monitoring for their location very quickly. It's very efficient, simple.
So wenn das mal konfiguriert ist, mal eine Zeit lang läuft, fallen jede Menge an historische Daten an.
Okay, so if all of this is configured and it's been running for a while, then there's some history, of course. Configuration is on the master and also all the different Hydra heads, so all the slaves really. So this configuration is just a copy there, but there's still historical data that you have to save. You don't want to lose that in case of a loss of your Hydra head. In order to do that, we wrote a script that always is the grunt job at midnight local time, and that is then the only backup. And this TGZ file is then encrypted using PGP. And there is a public key for that. The private key is only available to my team. And then this encrypted backup is then transported via FTP to a central server, and there it is stored on an NSF mount that is then coming from a safe storage system. And of course, all of that is then also on tape in the computing center. So we have that backup done.
Zur SMS-Alarmierung. Wir haben ein global verfügbares USB-Modem.
Then let's say a few words about the text message alerts. We have a globally available USB modem that's been defined here. It's called the Centurion EHS6T. It's a plug-and-play for the user. He just plugs it into his Hydra head, and in the background there are two UDEF rules that create a link to dev modem from the TTY, and then it activates the text message tools called SMS here, It monitors the signal strength, it monitors whether the modem is actually registered with the provider. Then we also wanted to have a bidirectional communication. If the user receives a text or an SMS, then in the alert there's a 5-digit number, and this 5-digit number can be returned to the modem, and this is how you acknowledge the alert in CheckMK.
Leider kommt es immer wieder bei uns vor, dass es lokal kleine Desaster gibt.
Unfortunately, on a local level, there are sometimes small disasters. So something happens and several hundred alarms are being sent out. With text message alerting, I mean, email is already inconvenient, but with the text message alerting, you're really stressed out already, and then the mobile keeps beeping. So that's how we introduced this water snapping, that the SMS alerting can actually be switched off, so you're at least being left alone by your phone. Then you can fix the problem, and then all the alerts that all still go into the SMS queue, they can be cleared from the queue once you have fixed your problem, so that the leftover alerts are not being sent out. This is an issue that did come up in real life quite a few times, so we think we found a nice fix here. That's all I had to say. I thank you very much for your attention. I hope that one or the other had or did have interesting facts to take away from this. We still have 12 minutes if you have questions now. Otherwise, I'm here in the break as well.
Ja, wir haben uns hier vorne gerade gemeinsam gefragt, wie habt ihr die Standardisierung erreicht?
Yeah, here in the front we were wondering, how did you get to this level of standardization? Like brute force, or political influencers, or money? No, it's a process that has been going on with us for a while. We know that in an environment of our size, IT can only survive using standards. It's something we did with Active Directory a long time ago. The team did a very good job on that. And we want to keep going down that road. Of course, it is painful in the beginning, sure. We do have our level 2 teams, the infrastructure managers, who support us strongly and who support the local sites, who also work from an everyday practical approach. And we do cooperate with them closely to make sure that the standards are defined properly. But of course, sometimes there is resistance to that.